So this is a good opportunity to talk about some details, like security misconfigurations are some of the things that are overlooked, but today we're going to discuss them from many angles. Hello, my wife is also here, so hi. Okay, guys, so I'm going to introduce myself first. My name is Jorge. I'm a CDev here at OffSec. You'll probably, if you go to the SSD exercises channel, you're going to find me there. Also, the Web 100 exercises. If you want to find me on socials, that's my InfoSec Exchange Mastodon account and my Pokemon Go account. So go at me if you play Pokemon Go and follow me if you have Mastodon. Here at OffSec, I focus on secure software development, and I also do some attack stuff, but I mostly focus on building things. So this is what we're going to talk about today. Waving Manta, thank you for taking this time. Thank you for joining me. So no need to thank me. All right, so I was reading that this is the 20th anniversary of the Cybersecurity Awareness Month. So that's great. It's awesome to be able to talk to you and hang out with you guys today and celebrate this. All right. So the first thing we're going to do is that we're gonna talk about what the plan is for today. Okay. So this is the plan. First of all, don't be afraid to ask questions. Don't be afraid to interrupt me at all. You're not interrupting. You're contributing to the conversation. So this is not a classroom. This is a conversation between me and all of you guys. So feel free to ask questions at any time. We're going to talk about what configurations are. We're going to talk about common misconfigurations in our personal lives. If any of you guys are home labbers or self-hosters, we're going to talk about misconfigurations in those environments. And finally, we're going to talk about, the quote unquote, the most important thing, which is enterprise misconfigurations. So let's start from the beginning, okay? What's a configuration anyway? Who's that Pokemon? So a configuration, like the dictionary says, that a configuration is an arrange of software and hardware, right? Like the components that make the whole thing work, that's a configuration. Like that can be like parameters, that can be where the software is running, the hardware we're using to run the software. Everything is part of that configuration. So there are many places in our configuration where we could make mistakes that could lead to security problems, right? So what's part of a configuration? Basically everything, okay? So user accounts are part of a configuration. The runtime parameters, what we define in our, like when we are running, for example, a Node app and we're using the .m file, that's part of our configuration. The version of a plugin we use. So for instance, we're using, I don't know, Guzzle. If in a PHP app, Guzzle it's a module to consume APIs. Well, that's part of the version of that. It's part of our configuration. The presence or absence of specific things is part of our configuration. So for instance, if our workstation is running or not running an antivirus application, that's part of our computer's configuration. And finally, error handling, how we deal with problems, that's part of our configuration. In production environments, a common problem is that sometimes when you're using like the default setup of a framework, for instance, when there's a crash, when there's an exception, like the way they're presented back to the user contains stack tracers. So those stack traces can contain sensitive information, can contain names of files, can contain names of classes, can contain a lot of things that should not be seen by our users. So that's all part of our configuration. Now, let's talk about misconfigurations. This is when we make mistakes, right? Sometimes using default configurations is secure enough, but sometimes it can lead to problems. And that's part of what we're going to discuss today. So let's talk about our personal misconfigurations, okay? Well, one of the things that is super common, and to be honest, I'm guilty of that. I was doing that when like a few years ago, I was still doing this. I would reuse my passwords everywhere. Like it was easy to remember, and to be honest, the risks of a teenager, reusing passwords are not the same risks of someone who's 35 years old reusing passwords. So that's why I want to emphasize the fact that threat modeling is important, because my risks are not the same as yours. So we need to be aware of what we are defending from. However, regardless of what we're defending from, the reusing passwords is a problem, because if there's a leak in one platform that we use and our password is used by an attacker somewhere else, then the problem is more significant for us. So another thing that another thing that is a misconfiguration, and some people don't think about it too much, is that if we keep our passwords and our two-factor authentication tokens in the same application, right? If an attacker gets to compromise one single place, they have access to everything. So although like most password managers support having 2FA tokens in them as well, ideally I recommend people to have separate apps. So you can have, like, for example, I'm a Bitwarden user, so I use Bitwarden for my passwords and Authy for my 2FA tokens, and it's served me well so far. So that's what I recommend you do. There are many options, right? Like for password managers, you have 1Password, you have Bitwarden, you have LastPass. Well, I'm not going to talk about the scandals of LastPass in the past few months, but they're still an option. So in our personal lives, going a bit away from credentials, let's talk about how we access the web, right? Up until a few years ago, having an ad blocker and an anti-fingerprinting solution was something like only nerds would do, right? Yeah, definitely. I mean, having 2FA is an upgrade regardless. I mean, but still, if you want to strengthen your posture, it's ideal to have them in separate places. So going back to what I was saying, anti-blocking, anti-fingerprinting, it's something relatively new. And here's the thing. I know, and it's a known fact that some businesses are supported by ads, and that's okay. It's fine. But the problem is that ad networks lack the required moderation for ads to be safe, right? And I'm not talking about only phishing. I'm talking about malware as well. Ad networks are known to be common vectors of malware distribution. So they're dangerous. That's why we need ad blocking. And some browsers support that more than others, but we can still, work against the tide in the browsers that don't allow an easy way to have ad blocking. We'll discuss that a bit later. And anti-fingerprinting. Okay, fingerprinting is something that we don't think twice about, but it's important. So here's the thing. Anonymity is something that we don't always need, but when we need it, it's kind of critical, right? And we don't realize how unique our configuration can be, right? So the browser configuration, now we're talking about configurations again. So for example, the size of our monitor, like the resolution we're working with, the APIs available on our browsers, the country we're from, the IP we're using to access a particular website, those things individually might seem like they provide good anonymity. However, when you put them together, you have no idea how unique you are. And there are websites for you to test that. So if someone wants to track you, in your day-to-day activities, using those variables together makes it easy for them. And one of the most common ways to do that is with canvas fingerprinting. So there's an API in browsers that allow websites to draw like vectors, and those vectors can be hidden, So those canvases are used to draw random values, and those values are combined with the rest of the variables a website has about you, can be put together to uniquely identify you every time. So that's why anti-fingerprinting is important. Now, the ones of us who use Android phones, side-loading apps, okay, that's the freedom we have when we get an Android phone. That's great, but we need to be aware that having the same package name of another app can be a way for us to create a malicious version without the user even noticing. So how do we notice, like, what's the easy way to notice if we're installing a malicious app? So here's what I usually test. You first start with a known good version of an app. So you download it from Google's Play Store, right? And then you try to sideload the version of the app you want on your phone. If it can't go through, then it means that the app was signed with the same key that the author of the app used, which means it's good. However, if you can't install the app on top of the one you already have from a known good source, that means that it was tampered. By whom? I don't know. Maybe some developers have two signing keys, one for internal distribution from the store and one from direct distribution for users, but that's not always the case. So that test is a good one for you if you want to know if you're using a good side-loaded app or not. Also, you can do that manually, like you can generate the signature using a command line with ADB and all of that. But if you don't want to go through that hassle, just seeing if you can install it on top of the other one is a good enough test for most of us. Keeping unused features off on your cell phone. So let me go back to the OOs here. There was a time, probably 2005, 2006, when people from marketing departments thought it was a great idea to start beaming files to Bluetooth devices all over the place, and you would get images, you would get jingles, you would get like random things on your phone. That was terrible. And nowadays, I mean, they don't use it like that anymore, but attackers do. So if you have unused features like unused radios or even NFC, try to turn them off. So it's not as common because there are controls that have been implemented to prevent this type of attacks, but relay attacks on NFC payments are a thing. So how does this work? The attacker needs a device, right? Like another Android phone or maybe a Raspberry Pi with a battery. What this device does is that it poses as a point of sale terminal. And your phone, like with Google Pay or Apple Pay or whatever, tries to make a payment. And that's how they supposed to work, right? If you don't have you don't have your phone configured to ask for credentials before going through with the payment, then it's possible for the attacker to pose as a point of sale, then beam that to another device and complete the transaction. That's a relay attack. So that's why I don't like NFC. I don't like it to be enabled at all times. And although those types of attack have become rarer because of some controls that have been implemented by Google Pay, by Apple Pay, I still like to play on the safe side. And since we have people from Latin America, I also think about threat model specific misconfigurations. So here in my country, it's kind of dangerous to say the least. So it's dangerous for a person to have the bank app installed on their phone because it's not uncommon for criminals to just, they're called express kidnappings, right? They pick you up somewhere, they take you to a location and they force you to either withdraw money with your ATM card or to transfer money to their accounts from your cell phone app. So some people have just started to uninstall bank apps from their phones, and that's super common here where I live. There are also other ways to hide that, right? So with phone launchers, what's a launcher? In phones, there are apps that can control the desktop environment of the phone. So in the case of Samsung, for instance, that launcher is called One UI. So there are other launchers, like there's Nova, there's Trebuchet. So if you use a launcher that supports it, you can change the icon of an app, you can hide an app. So there are ways to mitigate this particular risk. And now to the phone part, self-hosting. Why though? Okay, now let me tell you why I self-host, okay? It started back when I wanted to get my OSCP, to be honest. I am a programmer. I've been a programmer for more than 10 years, but my know-how of systems administration and infrastructure was not as good. So I started to self-host things. I started with, a custom firmware on my router, and then I got a NAS, and then I got a server, and it started from there, and now I can't stop. Someone help me, please. So misconfigurations in self-hosting and in home lab environments. Well, all of the ones we mentioned, like for particular uses, like for personal uses, apply here, but let's discuss some more. All right. I'm talking about home labs in the sense that your house is your playground. So let's keep that in mind. In network, like in corporate network environments, it's common for people to use network segmentation. But in home environments, that's not the case. However, router vendors have started to make that an option. Any average router you buy nowadays has what it's called a guest Wi-Fi network, which means that the clients that connect to that SSID are isolated from the ones that are connected to your regular SSID. That's great, right? You can give your Wi-Fi password to your guests, and they won't be able to access your local infrastructure. That's great. But here's the thing. Now that IoT devices are so prevalent, it's not a good idea to have them on the same network where your cell phone, your laptop, and in this case, the servers reside. So we can, if it's possible, like with smart switches or with smart plugs, we can send them to connect to the guest Wi-Fi network, so that in case it's not something that hasn't happened before. I don't know if you guys remember the Mirai botnet. The Mirai botnet was basically an attack where they were using unpatched IoT devices and routers to launch DDoS attacks. So that's why it's a good idea to not trust IoT devices. So that's why, even though I have them, I prefer to isolate them, and it's always a good idea to do that. In case they get compromised, they will have internet access, yes, but they won't be able to reach your local infrastructure. Now, remember when we discussed having ad blocking? So if the browser you're using doesn't play nice with plugins, with ad blocking plugins, we can use another approach. We can use DNS-based ad blocking. So in my case, I use Pi-hole. Pi-hole is a ready-to-use DNS server that you can set up on your network. It also works as DHCP, so that it assigns IP addresses on your network. And then you can set it up with lists of, I don't know, known malware distributors. You can even define the host names of particular ad networks you don't like. In fact, you don't even have to do it yourself. There are pretty established lists of things that we can block, so that we are relatively safe. The minor issue with this is that it might require some tweaking, because sometimes those lists include host names that are used for legitimate things, and that might be a problem sometimes, particularly on sites like Amazon. Like, you need to tweak Pi-hole's default configuration if you want the Amazon app to work out of the box. So another problem we've seen in the self-hosting community is that some people expose a NAS to the internet. And you're saying that there are good solutions of NAS like hardware devices that are super easy to use. Like, you just plug the Ethernet cable and everything should be good to go, right? They publish it as your own cloud, quote unquote. The problem with that is that it doesn't stop being an IoT device, right? And those things require patching, and sometimes the vendors don't patch, don't supply patches for all the devices, at least not in time. So there was a ransomware campaign, like I think it was a year or two ago, that would target Drobo devices, and that would also target Western Digital NAS devices, and a lot of people got affected by that, and it was super, super bad. So you need access to NAS. So what do? So you don't expose things directly to the internet. You can set up a VPN server, right? A good way to configure your home lab is that you don't access your servers directly. You use a VPN. So you can, if you have a public IP, you can set up an open VPN. Some solutions like OpenSense and pfSense make it basically a couple of clicks away from being installed. But if you want to do it manually, there are GitHub repos that have SH files that you just run them, and you can set up an OpenVPN server on Linux. Super, super simple. Now, if your ISP does not, provide direct access to your network, I mean, you have CGNAT, carrier grade NAT. That means that the IP you see as your public IP is not the same one that gets to the websites you access, right? You check the IP on your router and see a value, but you go to what'smyipaddress.com and you see another value, that means that you're netted somewhere. But that shouldn't be a problem for self-hosters nowadays. You can use, basically, these services I listed there are called overlay networks that provide a VPN by using intermediate nodes. Of course, they support zero trust, so everything's encrypted along the way. In fact, Tailscale, for instance, it implements another protocol called WireGuard. Is that the name? Yeah, WireGuard. So even though you use what they call derp servers along the way, right? You can't access your VPN server directly. You use like nodes in the middle, more or less like when you use Tor, for instance. Like there are nodes in the middle that route your packets. It's the same thing here. So if you don't have a public IP, you can use these services. Like there are options. There's Tailscale, there's Zero Tier, NetMaker, Nebula. They have different implementations, but they're all good. Personally, I use Tailscale. I've had great results. Nowadays, I have a network between my house and my parents' house, and none of them has a public IP, so it's been great so far. I can recommend it. Now, more misconfigurations in home lab environments. So here's the thing. Sometimes in our house, like we have a service, and since it's our house, right? And we also have a guest network, so visitors won't be able to access that. But it's still a misconfiguration if a service that is technically open is accessible without authentication. However, it shouldn't be a problem. So what can we do in those cases? We can use a reverse proxy. So the thing a reverse proxy does is that it becomes an intermediate step between you and the web server, right? So it forwards the request and returns whatever the web server sends you back. But it can add additional layers. So you can add, for instance, you can add a WAF via a reverse proxy. So a WAF is a web application firewall, right? So it intercepts malicious packets and it can either log them or reject the request. So we can, add that in as part of the reverse proxy. We can also add caching, in our reverse proxy. If we're serving static content, the reverse proxy can keep those static files so we don't have to ping the other end every time. And finally, one of the other uses that we can give a reverse proxy is to add authentication. So we can add, for example, basic HTTP authentication, so that even if our service is completely open, we are required to authenticate before accessing it. And to do that, we can use Authelia, we can use Authentic. There are many options there. Personally, I've used Authelia and I've had good results. Now, in my home lab environment, I have many Docker containers. The entry barrier for installing things is much lower now. Like I remember there used to be a time where, we would have install documentations that were awful to read. It would take you an hour, 2 hours to install an app. But, okay. That's a great question. Let me pause what I was saying. So Piranha is asking, how do you get notified if you have a new unexpected connection on your lab or network? From your firewall? Okay, so there are many things I can do. One of the things I do and I like is that you can have many ways to get notified if something happens on your home lab. The thing I like is that my local devices have static IP addresses. So I know their MAC addresses at all times, and I know which IPs map to which MAC addresses. That's my base configuration. However, if my DHCP server gets pinged because there's a new device either on the Wi-Fi network, or the Wi-Fi VLAN, I mean, or the Ethernet VLAN, then I know that there's something new. And I used to have an alert, but it's annoying when I have visitors. So I just check the DHCP leases every once in a while. But setting up an alert is also an option. That's on the network side, but on the application side, right? There are log processors. Like, for example, fail to ban is a log processor. You give it access to your logs, and you can configure rules so that if something happens, you get a notification, right? So you can define, like, on your, for example, your WAF logs, a particular event, and then from fail to ban, you can just parse the logs for that particular event, and then either get notified about it, or you can block the connection altogether. So yeah, we can use fail to ban for that, or we can use a network-wide approach for that. Again, these are not enterprise ready like approaches. Like, these are great for home environments, but in enterprise environments, you would need to have a full blown SOC team for that. I don't know if that answers your question, Pranya, but that's what I do. And for everyone else, if you have questions, please, even if they're not related to what we're talking about, just drop them on the comment section. Okay, so here's some final thoughts about home labs and self-hosting. Okay, RAID is not a backup. Okay, it's just a way to have some peace of mind, but it's not a backup. Okay, I can't trust my NAS because it can completely explode, and RAID would not be useful in that event. So you need to follow the 3-2-1 rule, right? The 3-2-1 rule is that you need 3 copies of your files, right? 2 in different formats, and 1 should be an offsite backup. So in my case, I have my NAS. I also have another box that mirrors the NAS files, and I also mirror those files to Google Drive, but like a custom domain Google Drive account. And that's something interesting I learned in that process. So there's a Unix tool called rsync that it basically synchronizes to directories, and it works great. It works over SSH. It's awesome. I love it. However, there's an alternative to that for cloud services, and it's called rclone. I use it to sync my backups to Google Drive, and it's been great. However, one configuration mistake I made when I started using it, and that's why I mentioned it, because it's a good learning opportunity for you. May my mistakes be your learning. is that I used like my account credentials for that. And one day I was thinking, what if my NAS gets compromised, right? They would have access to my Gmail, they would have access to Google Drive, and I would be in a very bad situation. So I tried to investigate what my options were. And there's a thing called service account. So you can delegate access to particular things to a service account. And with those service accounts, you can, for example, I defined that the service account for my NAS backups has only write permissions on a particular directory where my backups will be. So the rest of my files will be safe if that account gets compromised. And it's good because it's easy to recycle, and also it doesn't have a password. It has a super long random key that it's not easy to brute force, which is also a plus as well. And also I don't have to write my basic password now somewhere else. Okay, so now that we've talked about backups, remember to test your backups. It's important. You don't want to wait for the moment when you need your backups to test them, right? You want to make sure that the moment you're going to decompress the tar file or whatever it is you're using, your files are going to be there. So what I do is that when I automated my backups, right, I define some validations that if the tar command fails, or if the rclone command failed, or if any of the steps failed, then I get a notification. But here's a cool thing. There's a service, or you can self-host it. It's called healthchecks.io. Let me type that there. So what this does is that it expects a request from you, right? Like you need to send a curl request or a wget request, depending on a schedule, right? And if that service is not pinged at that time with that frequency, then you get a notification that something is presumably down. And that's what I do with my backups, right? I make sure that at all steps they are not corrupt, and if they are, then I check them. However, I mean, a bit besides all that, I also download one backup once every couple of weeks to make sure that everything's there and everything works. Also, if you're starting in this world of self-hosting, try not to self-host mission critical things. So what I consider mission critical in my case are email and password management, right? I mean, you can do that, but it's a lot of work, like particularly email. Dealing with spam is not something you want to do for fun. So unless you want to put yourself through that as a learning experience, I would advise you not to bother. And also password manager, right? I will leave that to someone whose day job is to do that, because if I make a mistake with my passwords, then I will be annoyed for a few days, to say the least. So I don't want to put myself through that. And I mean, my mission critical things are not your mission critical things, but the message is that, right? Now, don't self-host your mission critical services. Now let's talk about corporate environments, and I'm going to give you an anecdote here. What's the subject for today? We're talking about security misconfigurations. Hi, Isa, Todd, Van. Hi. So yeah, we're talking about security misconfigurations and corporate environments. Okay, let me give you an anecdote here. This was many years ago, right? In a place where I used to work, like we used to share the root password of all of our servers, and I wish, root password were a typo. No, I actually mean that we had the same root password for all the servers. Like it was ridiculous in retrospective. So here's the thing. I mean, creating server accounts on a Linux box is free, right? You can create as many accounts as you want. So it made no sense to share the password, and even less sense to share the root password. That's a terrible misconfiguration there. So in fact, here's the thing. Some hosting providers, like I'm not going to give you names, but probably 10 years ago, their default configuration would allow, SSH access with the root account by default. So that was not a good idea. If you use like a default Amazon AMI for in EC2, you'll notice that you can't log in with root, and you can't log in with password. So those are super good configuration changes that are the default. So here's, and that takes me to the second item, right? Default parameters might not be secure parameters, and you need to trust whoever provided that piece of software to know better. So if you're not sure, make sure you take a look at the documentation to know if you need to tweak something. Accounts created by the vendor are super common. So let me give you an example. In the case of OpenSense, when you create when you create the default configuration, when you finish installing it, right? You get an OpenSense account which has a default password of root, and it's up to you if you change it or not. So they even have a documentation page for that. Also, for instance, another case is Synology NAS. They have finally come to peace with the fact that some people will expose those devices to the internet. So they know that there's a default admin account, and they know that people will try to brute force that account eventually. So they even have a documentation page about creating a new account with admin privileges and completely nuking, like deleting altogether, the default admin account. So again, you need to see what default accounts you have in every circumstance, so that you can take care of that, either disable them or delete them altogether. Now, we talked about OpenSSH with the case of being able to log in as root, or being able to log in with the password instead of a private key. But there are also other default configurations that are dangerous in some scenarios. So for instance, Apache, let's talk about Apache here. And in some default configurations of Apache, you have directory listings enabled. What directory listings do is that, so you have the bar www HTML directory, which is the place where you put your server files, right? Like the files you want to share with the public on the website. So if you have another directory inside of the HTML directory and you have files there, and if that server has directory listings enabled, when you open the URL of the directory, you're going to see a list of all the files that are there. That is not dangerous in and of itself, but it can help an attacker get a good idea of what you have, what you're hosting. Sometimes if they can download things, those things can have sensitive information. And that's not to say that just because they are not able to see the list of files, they won't be able to download them. There are other options. Attackers have ways of brute forcing directories by fuzzing. Fuzzing is basically a testing technique where you send values to a server, like with a dictionary, a list of common names, so that you can find quote unquote hidden files there. So even if a directory is not listable, you could probably use a tool such as GoBuster or FFUV to find things. But still, you don't want to make things easy for them. Another misconfiguration of Apache is when you let the headers of the responses show too much information, like versioning information. Like you're running PHP 5.6 or you're running Apache 2.4.30 or something like that. I know it's not too bad to have that, but if there's a vulnerability for that particular server and you have that information there, it's easier for an attacker to exploit it. So that's why it's better to just hide it altogether. Programming frameworks also can have default parameters. And so, for instance, some programming frameworks set the development as the default environment they run as. So when there's an exception or there's an error, you get a nice looking stack trace with the line where the error happened. If you were using particular variables, you can see the values the variables had. That's nice for a development environment, but not for a production one, right? You don't want an attacker to know how you wrote the app. In fact, sometimes those error messages can leak internal paths on the server, host names, in fact. So you don't want that. You don't want that to leak. So make sure you familiarize yourself with the default parameters of your programming framework before you send an application to production. Okay. So accounts created by the vendor, we already talked about that with OpenSense. With well, MySQL is an interesting case because when you install a MySQL server, you can just log in with root with no password. It's up to you to change it. So you need to make sure you do that. Also, all software components. All software components are not dangerous just because they're old, are dangerous because you might not be aware that they're old and they have vulnerabilities associated to them. But I guess we need to understand that updating software is not always an option. So we have other alternatives, like in OT environments, like when in factories or things like that, they have software that only runs on Windows XP or Windows 7. So it's not an option to update that. So what they do is that sometimes they air gap those servers. Well, what this means is that they isolate them from the network completely. Like they even remove the physical network interfaces on those devices to secure them. There's also another approach, which is installing them as a virtual machine and removing the network interface from that virtual machine. So even if we can't update, we have other options. And clear text parameters. When we fire up a Docker container, we usually need to define passwords. So if we leave them as clear text, it's going to be dangerous for us. So there are approaches to mitigate that, like Docker secrets or HashiCorp's Vault. I don't want to leave you without the opportunity to ask me questions. So the last item we wanted to talk about was error messages, which we also discussed previously. So if you have any questions, please drop them in the comment section. And also, thank you all for joining me. It's been great. I'm in this section with you. So ask your questions, but if you don't have any, that's how you'll find me on Discord, on OffSec's server. I usually hang out on the SSD channels and on the Web 100 channels. So don't be shy and say hi. I hope you all have a great weekend. Thank you for joining me. It's been great having this session with you. Thank you, and see you on the next one.